So if we're going to look here at our particle diagrams, this is going to help us get a better idea of what's going on with our states of matter. So we're going to start over to the left with the least amount of kinetic energy. So with our kinetic energy, it's the lowest on this end. So we're increasing the kinetic energy as we go this way. So the lowest amount of kinetic energy we would have means that we have a solid. And we know it's a solid because we can tell that the particles are very closely arranged. There's not a lot of space in between them, and they're vibrating at fixed positions. Now we're unable to see that from the picture, but it's one of the properties about solids is that they vibrate slowly and it's at a fixed position. Now, the other thing about solids then that we would want to notice is that because of this closeness and arrangement, we have a definite shape. We can look at this and go, okay, this item's a square. It's a definite shape. We also have a definite volume. We could measure how much space this object is occupying, which gives us a definite shape and a definite volume. So there's our particles of a solid. Now, we have different types of solid. We have crystalline and we have amorphous that we'll talk about later in one of the other videos. Now, if we move this way and we continue to increase energy, so there's more kinetic energy here, the particles are allowed to start breaking away and we get a liquid. Now, in a liquid, the particles are still close together, but they're a little bit more disorganized, and they're able to move past each other by what we call slide and glide. And what we mean by slide and glide is that some of these particles have more kinetic energy than others, and so they're able just to continually move. Now, because of that, we have a definite volume. I can measure how much is in this beaker, but we have an indefinite shape. The shape is going to be able to switch and change to its container because of the sliding and gliding. If we continue to head over and increase energy more, the particles are able to break free from each other and we get a gas. In gases, the particle diagrams are going to show the particles further out, spread out, and they're causing collisions. So collisions are very big in our gases because the particles are going to expand to fill that container. Because of this, we have an indefinite volume. This beaker is open. Particles can leave, particles can come in. It's an ever-changing volume. We can force more in, which is pressurizing, or we could remove some, and then that would change the pressure as well. So in gases, we have indefinite volume, and we definitely have an indefinite shape. If we continue to go over the last state of matter that we have with the highest amount of kinetic energy, so this would be the highest right here, is going to be plasma. And plasma is going to be so charged because of the faster moving particles, the highest amount of kinetic energy, we get these little ions or these charged pieces. And so in a particle diagram, we see the charged particles. Also an indefinite volume, indefinite shape, but what makes it different than a gas is it has charged particles to it. So these are just our different states of matter. Now if we start talking about what the change of state is that occurs as we go one way to the next.